guys, Assalamualaikum. Today we proceed to hypothesis testing but focus on one population mean. First, let's look at the introduction. Statistical hypothesis. So, hypotheses that are stated in such a way that they may be evaluated by appropriate statistical techniques. Hypothesis testing can be performed if a certain person is making a decision about a population parameter based on the value of a sample statistic. And then hypothesis. So hypothesis is a statement about a population parameter that may be true or false. So we will set up the hypothesis based on null hypothesis, which is denoted by H0, and alternative hypothesis, which is denoted by H1. So the purpose of hypothesis testing is to test the viability of the null hypothesis based on experimental data. So this one, the difference between null hypothesis and alternative hypothesis. So this one, types of error. So first error is type 1 error, known as alpha error. So a type 1 error is committed if the null hypothesis is rejected when it is true. Second error is type 2 error, known as beta error. So type 2 error is committed when the null hypothesis is not rejected when it is actually false. So this one, the actual situation and the decision made after test, either correct decision or alpha error or maybe beta error. Let's focus on rejection region and also the assumptions. Rejection region is the region where the null hypothesis is rejected. It means that there is enough evidence to reject the null hypothesis. Look at here, two-tailed test. So two-tailed test here based on alternative hypothesis. Based on the symbol here does not equal to mu naught. So when you want to draw a rejection region like this, two line here, and then the rejection region here, this one right side and also this one. So both shaded region known as rejection region. Okay, next. All the assumptions must be considered when a researcher chooses a test and when interpreting the results obtained either for one population or more. For example, z-test and t-test must be used for populations from which the sample data drawn are normally distributed and independent. And then the main difference between the z-test and the t-test is the assumption of the standard deviation or variance, whereby if the standard deviation is known, we will use z-test. If not, use the t-test if the sample drawn less than 30. And then the standard deviation or the variance value will be computed from the samples. Let's look at the examples on how to set up the H0 and H1. First example, is the population average working hours in biocomposite plant different from 12 hours? Therefore, H0 mu equal to 12, H1 mu does not equal to 12. From the word different from 12 hours. Second example, is the average cost of a piece of 3-ply plywood less than or equal to Rm20? So this one, left tail test. So why left tail test? Look at the H1, mu less than or equal to Rm20. And last one here is the average amount spent in the furniture store greater than Rm250? So this one, right tail test. So right tail test mu greater than Rm250. So this one, the examples on how to set up the H0 and H1 two-tail test or one-tail test. Let's focus first case. So first case here is population is normal and variance is known, or standard deviation is known. So the word known here is based on population. So there are 5 steps to test the hypothesis testing. So first step here is set up the H0 and H1. Second step, calculate Z calculation. So this one, sigma value. So sigma value means from the population. So sigma represents population standard deviation. Third step. So third step here is find the critical value from the Z table. And then the rejection region. So look at here. First one, the rejection region, left tail test. Why? Look at the H1. So H1 mu less than mu naught. Second one, mu greater than mu naught. That's why right tail test. So the rejection region, right side. And last one here is two tail test. Mu does not equal to mu naught. Therefore, the rejection region, left side or right side. Step number 4, make a decision. So make a decision. Here is either reject H0 or fail to reject H0. And last one here is step number 5, make a conclusion. So this one, 5 steps to test the hypothesis testing if the standard deviation or variance is known. But you must remember that if the values from Minitab software output, we will reject H0 if p-value less than alpha. Look at first example. The breaking strength of a special cable is normally distributed with mean and standard deviation of 800 pounds and 12 pounds respectively. A researcher selects a sample of 20 cables and the average breaking strength is determined to be 793 pounds. Thus, the claim at alpha equal to 0.05 that the mean breaking strength is 800 pounds. So first, based on this example, list all the information. Mu equal to 800, sigma equal to 12, and then sample size 20, sample mean 793, and last one, alpha equal to 0.05. First step, set up the H0 and H1. So H0 mu equal to 800, H1 mu does not equal to 800. Based on this statement is 800. Second step, calculate Z calculation. So substitute all the values. Z calculation equal to negative 2.6087. And then find the critical value. So since this one is 2 deltas, so alpha divide by 2. 0.05 divided by 2, 0.025. So from the Z table, the value equal to plus minus 1.96. And then you may construct the rejection region. So where is the rejection region? Left side and right side. So where is negative 2.6087? Left side here. Is it in rejection region? Yes. Therefore, reject H0. So what is the conclusion? At 5% level of significance, we can conclude that the mean breaking strength is not 800 pounds. So we will conclude based on H1. Mu does not equal to 800 since we reject H0. Second example, same study, but this one tests the claim at alpha 0.05 that the mean of breaking strength is less than 800 pounds. So this one less than. First step, list all the information given and then set up the H0 and H1. So H0 mu equal to 800. Meanwhile, H1 mu less than 800. So less than based on this statement. Less than and then less than. Next, calculate the Z calculation. Substitute all the values. Then final answer for Z calculation equal to negative 2.6087. Okay, step number 3. Find the critical value. So this one tail test. So one tail test, use alpha equal to 0.05. Read from the table. Critical value equal to 1.6449. So where is the rejection region? Left side. So left side here. This one. Negative 1.6449. So what is the decision compared to this value? Is it in the rejection region? Yes. Therefore, reject H0 because Z calculation less than negative 1.6449. So when you look at here, negative 2.6087 in the rejection region. Therefore, at 5% level of significance, we can conclude that the mean breaking strength is less than 800 pounds. So this one, based on Minitab output. So first, look at here. Minitab output, one sample set. So one sample Z means that variance or standard deviation is known. And then look at here. What we need to test? Test of mu equal to 800 versus mu less than 800. Same as example 2. And then this one. The assumed standard deviation equal to 12. Next, in Minitab output, so this one is a sample size 20, the mean value 793, which is X bar. And then standard error of mean 2.68. So how we want to calculate manually to get 6.28? So this one calculated based on sigma over square root n. So sigma 12. And then n equal to 20 equal to 2.68. Next is 95% confidence interval. So this one, 95% confidence interval in between 787.74 and 798.26. And then this one is Z calculation. So Z calculation equal to negative 2.61. So when you calculate manually, same answer, negative 2.61. And last one here is the p-value. So p-value equal to 0.005. So test the claim at alpha equal to 0.08 that the mean breaking strength is less than 800 pounds. So first step, H0 and H1. So mu equal to 800 versus mu less than 800. And then what is the p-value? 0.005. The alpha value equal to 0.05. And then the decision here is reject H0 because the p-value less than 0.05. So alpha equal to 0.05. Therefore, same conclusion as example 2. So this one, the comparison on how to do the hypothesis testing using the calculation value and also using the Minitab output. Second case, population is normal and variance is unknown. So this one based on small sample size which is less than 30. So less than 30, recall back the confidence interval approach. So confidence interval when the variance or standard deviation is unknown and the sample size less than 30, we will use T distribution. So this one, 5 steps on how to test the hypothesis testing. Step 1, H0 and H1. Second step, test statistics. So this one, T calculation. Step number 3, find the critical values and also the rejection region. And then step number 4, make a decision, and last one, make a conclusion. So same as first case, if from the Minitab output, we will reject F0 if the p-value less than alpha value. So look at example 4. A random sample of 20 batteries had a mean of 138.47 and a standard deviation of 2.66. Assume that the distribution is normal. Is the average capacity of batteries at least 140? Test at the 5% level of significance. So this one, what is the question here? Is the average capacity of batteries is at least 140 ampere hours. So first, as usual, list all the information given, the mu and x bar s, and also the alpha value. And then first step, set up the hypothesis mu equal to 140, and then for H1 mu at least 140. So this one tail test. Second step. So second step, calculate the statistical test value. So this one we will use T calculation. Why T? Because the standard deviation is calculated based on sample, and then the sample size is less than 30. Then substitute all the values. The T calculation equal to negative 2.5723. Third step, find the critical value from the T table. So here alpha equal to 0.05, and then degree of freedom equal to 19. 20 minus 1. So from the table, the critical value equal to negative 1.729. So where is the rejection region? Left side. So left side, negative 1.729. Here. And then this value, is it in the rejection region or not? Yes, in the rejection region. Therefore, reject H0. And then what is the conclusion? At 5% level of significance, we can conclude that the average capacity of batteries is at least 140 ampere hours. Let's try example 5. A report states that the mean number of students using the wood machine per hour is 20. A technician selects a day at random, and the number of students who use the wood machine each hour over a period of 8 hours is as follows. At alpha equal to 0.1, thus the claim that the mean number of students using the wood machine per hour is 20. So this one, given the data based on 8 samples. So first step, what you need to calculate is calculate sample mean and sample standard deviation. So when you calculate sample standard deviation, automatically you will use T distribution. So x bar equal to 21.625 and the sample standard deviation equal to 2.9731. So first step, set up the hypothesis testing H0 and H1. So this one, two-tailed test. Next step, calculate the T calculation. So T calculation equal to 1.5459. Find the critical values. So from the table, when alpha equal to 0.05 and degree of freedom equal to 7, the critical value is plus minus 1.895. So where is the rejection region? Left side, right side, here. So right side, 1.895, left side, negative value, 1.895. Next, look at this value, 1.5459. Is it in the critical region? So 1.5459. So the value of T calculation is not in the rejection region. Therefore, fail to reject H0. At 10% level of significance, we can conclude that the mean number of students using the wood machine per hour is 20. Let's look at same example but using Minitab output. So compare first case. Look at here, one sample T. So one sample T. Before this, one sample Z. So this one, hypothesis testing. Mu equal to 20. Mu does not equal to 20. So what is the T value? 1.55. So 1.55 same as this value when you calculate manually. And then look at here, mean. So mean means that sample mean X bar 21.63. Meanwhile, the standard deviation equal to 2.97, same as Minitab output. And then the most important value that we will look at from the Minitab output is the p-value. So the p-value here equal to 0.166. Is it less than alpha? Alpha equal to 0.1. No, the p-value is not less than alpha. So, what is the decision? Fail to reject H0 because the p-value is not less than 0.1 or the p-value is more than 0.1. So therefore, same conclusion as example 5. So now we will use confidence interval approach to test the claim. First, what we need to calculate is the sample mean and also the sample standard deviation based on the given data. So calculate sample mean equal to 46.5, sample standard deviation equal to 8.1955. So using this formula, we can calculate the 95% confidence interval for the population mean using T. So calculate at the end final answer for 95% confidence interval is in between 40.64 and 52.36. So this one final answer for question A. Proceed to question B. Based on the confidence interval you have obtained in A, can the claim that the amount of carbohydrates contained in 1 unit of a beef burger is more than 54 grams be supported? Give your reason. So how we want to answer this question? Using the confidence interval. So the claim is more than 54 grams. So 54, is it in the interval or not? No. Therefore, based on the interval, the amount of carbohydrate contained in 1 unit of a beef burger is more than 54 grams cannot be supported. Why? Because the value of 54 is not in the interval. So this one, how? We want to apply confidence interval approach to test the claim. Okay guys, that's all about the hypothesis testing based on one population mean. Assalamualaikum.